In this video, we're going to look at Unit 2, Lesson 1, which is Congruent Parts, Part 1. And we're going to figure out what the corresponding sides and angles in figures have to do with congruence. So first, you can just take a look at this image, and in your student workbook, you can just write down a couple of things that you notice and wonder. So pause the video, spend a minute or two doing that, and then come back. So you can notice various things about this. Remember that not everything that I say is all encompassing, so you could have other things. I'll just note a couple things. Maybe you noticed that this was the only blue figure. All the other figures are green. Maybe you noticed kind of these letters in the middle here. Maybe you noticed that this first figure is the only one with just letters. All the rest of them have the primes with them. Maybe you noticed in the figures on this side, we have like P and S are on this side. But over here, P and S are on this side. Maybe you noticed Q and R then are here on this side, but here they're kind of switched around. So R is on top, Q is on bottom. So Q and R are here, and then again, they're switched on these ones. Maybe you wondered, like, why are the letters changing? Maybe you said these kind of look like they're congruent. So are they congruent to each other? Are the figures congruent? They look like they might be rectangles. So maybe you're wondering if these angles are 90 degrees. Since there's no markings, are they 90 degrees? And again, you could have various other things. That's just a very quick overview of a few things that you could have seen. So then in activity 1.2, we're given these two triangles, and I want to bring your attention to this congruence statement here. So this statement tells us that the two triangles are congruent to each other, and it puts the letters in order. So remember that this tells us that A goes with D because they're both written first. B goes with E, and C goes with F. So it's almost as if you just grabbed ABC and you put it over here. And so you can kind of see what lines up: D with A, E with B, and C with F. So I want you to go ahead and on page 171 in your student workbook, I want you to answer the questions there. So take about 5 minutes or so and work on that, and then come back to the video. So push pause and then come back. So the questions, these are the questions that were on page 171. So it says, find a sequence of rigid motions that takes ABC to DEF. There's a lot of different ways that you could accomplish this. So just because I say it or don't say it, don't worry. That doesn't mean that your answer is wrong if it's not the same as mine. You may see that these two, and let me move this tracing paper for a second. You may see that these two look like they're a reflection. So one way, if you want to get this done in kind of one motion, is you could say that we would reflect it over this perpendicular bisector. You don't have to draw that in, but you could just state that. But if we had the perpendicular bisector, this would just reflect over the perpendicular bisector. And then you want to pick a segment of points that are images of each other or are the same. So B to E. So the perpendicular bisector of BE. You could also have used AD, or you could use CF. But if we reflect over that perpendicular bisector or fold over here, this shape is going to land on that one. So that's definitely one way you could have done it. You can also follow your sentence frames and you can kind of follow the order that's in those. So you could do something like translating ABC by segment BE if you wanted to get B and E together. So translate ABC by the directed segment. And then this could be any ones that you want to get together that are corresponding. So A to D or B to E or C to F. So I'm just going to do B to E. Then you would want to rotate this because now we've got 1 point set. So now we want to rotate another one over to its partner. So then you would want to say rotate ABC around, and this is the set point. So the point that you just got together. So around point E until, and then you pick what point is going to go where. So you either want to go C to F. So you want to rotate C all the way over to F, or you can rotate A over to D. It doesn't matter. So then around point E until, and I'm going to do A, until A coincides with D. So then you would just do that, keeping B set, keeping B set in place. So keeping that, like stick your pencil in that on your tracing paper and keep rotating around B until A lands on D. And then finally, you would want to do a reflection. So then you would want to reflect ABC across line DE there. So then, or AB, you could call it AB if you wanted. But so then reflect over that line, and then that triangle will flip up and C will land with F, and you'll have all of those pieces connected. So then if I just reflect this, it would look like this. So it would flip over there. So then it would flip over that line, be right on top of there. So what is the image of BC after this transformation? So what is BC on top of is basically what this is asking. And so BC is that segment, and it is on top of, let me get rid of these so we can actually see the letters. So it is on top of EF. So BC landed on top of EF. And then how do you know that those segments are congruent? So all of these motions that we used, so either reflecting over the perpendicular bisector or doing the translate, rotate, and reflect, you used rigid motions. So how do you know that those segments are congruent? Because rigid transformations keep the same shape and size. So since I did all rigid motions, all of those corresponding parts are going to stay the same. So then justify that angle ABC. So let me erase this stuff again. So that angle ABC, so this one, is the same as DEF, this one. And so we can see that ABC on the image landed on DEF on the original. So then you can see that it landed on DEF. And so those are images of each other. So they're congruent. All right, so then let's discuss this. So what can you say about segments BC and EF? So those two landed on each other, okay, and we can see them in the correct order here. They're both in like the last two spots. And so we know that these are going to be congruent, and we know this because there are rigid motions or rigid transformations that take BC to EF. And we know that rigid motions keep the figures congruent. So then what I want you to do is I want you to try to come up with a justification or a proof. That's just making a statement. So it's starting with the statement and trying to prove the end. So I want you to work with a partner or by yourself. And I want you to try to come up with reasonings for if two figures are congruent, then the corresponding segments are also congruent. So we want to start with the figures being congruent and give some type of logical argument as to why the corresponding segments need to be congruent. Then I want you to try to decide or talk about, does this argument work for angles? So pause the video, try something, write some type of argument down, and then come back to the video and we'll discuss it. All right, so here's an outline for a proof. And so let's just look at filling this in. Now, your proof did not need to be this much. So I just wanted you to try something and try starting with congruent figures and see if you could come up with some type of reasoning. So now let's look at this one and I'll fill it in. You can write it down if you want to, but you don't need to. So this one says, if figures are congruent, then there is a what that takes one figure to another. So if they're congruent, then we know that there's a rigid transformation that takes one figure to the next. Okay, because that's what rigid transformations do, and that's the definition of congruency. So if there is a rigid transformation that takes one figure onto another, then it also takes one segment, because that's what we're working with. That's what we're trying to prove. It takes one segment of the figure to another segment, just like it did for BC to EF. Okay, those rigid motions took BC onto EF. So we call these segments congruent segments. Or sorry, corresponding segments, not congruent. They are congruent, but we call them corresponding segments. So if they're the segments that move to the other ones, they're called corresponding segments. So since there is a rigid transformation taking one segment to another, those segments are congruent. So we know rigid keeps the same shape and size. So since the rigid motion is going to take one segment to the next to land on it, that means that they're going to be congruent. Therefore, if figures are congruent, then we know that corresponding segments also have to be congruent. Okay, so basically, if the figures are congruent, we know there's rigid motions that take the entire figure. So it takes this whole figure onto this one. And then similarly, that means it'll take the segments onto each other. So if the figures move onto each other through rigid motions, so do the segments. So therefore, the corresponding segments are congruent. So go ahead and write this on your reference chart, corresponding parts. So make sure you get this written down and make sure you see all of these markings on this picture over here, as well as the stuff down here. So pause the video and make sure you get that written in. All right, then activity 1.3. So in your book on page 172, you should see, you should draw a triangle. And then you're going to find the midpoint of the longest side. So whatever size triangle you want to draw, I've drawn two here. So then find the midpoint of the longest side. And you can fold your paper in half. You can just kind of take one finger in and just try and find the center. Then you're going to rotate your triangle 180 degrees around that point. So when you do this, when you rotate it 180 degrees around that point, these vertices will just end up touching. So if you just rotate it and match up these vertices, you'll be fine. And then I'll just do it for both triangles here. So I'm just going to rotate it around that midpoint. So now I have, you know, my original triangle here, my original triangle here, and then my new one. So then it says label the corresponding parts and mark what must be congruent. So my copy already kind of has it because I already have the angles marked, but I also want to mark the sides. So this side right here between the purple and yellow angle, or the purple and orange angle, is congruent to the one between the purple and orange in my new one. Orange and green here matches orange and green here. And then we have that middle segment, which you can mark up if you want to. So the middle segment is in both of those. So then down here, a similar idea. So I'd have this side is congruent to this one. This side is congruent to this one. And then that middle one. So then you need to make a conjecture, which remember, a conjecture is just a guess about this figure. So what do you think about what you just created? What does it look like? What might it be? So what's your guess as to what type of quadrilateral you have found? Think about the definition of the quadrilateral. And then do you know why the quadrilateral has to fit that definition? So how are you going to prove that it fits that definition? So try and think of that and then come back to the video after you've thought about it and written down a couple of things. All right, so you could have come up with various things, but maybe your conjecture was that this looks like it's a parallelogram. So you were like, I wonder if this is a parallelogram. Could this be a parallelogram? So you looked at the definition of a parallelogram, and parallelograms mean that opposite sides, so this side and this side, are parallel. So I'm just going to put the little arrows on them. So these sides are parallel, and then these sides are parallel if this is a parallelogram. Okay, so then this side would be parallel to this one. So the idea here is, can we prove with facts that those two sides are parallel? So not just by looks, but have you learned anything that would help you justify that those two sides are parallel? And you could have come up with various things here. So maybe you remember that when we do a 180-degree rotation around a point, it creates parallel lines. So when you rotate this, and you have this written on your reference chart from Unit 1. But so if you rotate around 180 degrees around a point, it creates a parallel line. So a 180-degree rotation around a point not on the line, okay? So that purple point is not on this line. So when we rotate around it, it creates this parallel line, okay? Another line that's parallel. So 180-degree rotation around a point not on the line creates a parallel line. And then we could have seen that both ways. So we could have rotated, and let me get rid of some of this. So we also could have looked at the fact that this rotating around this point also creates a parallel line when we do it the other way. When we rotate it this way, whoa. Let me lock these together so they quit coming apart. All right, so when we rotate that 180 degrees, we create another parallel line. So we've got both of that. So that's one way you could have talked about it. Okay, so there's one option. Another option is maybe you remember that rotating creates these two angles that are congruent. So you see these alternate interior angles. are congruent, and that forces the lines to be parallel. So you either said something from your previous reference chart about a 180-degree rotation creates parallel lines, or you said something about alternate interior angles being congruent, which also creates parallel lines. And then that would make this a parallelogram. All right, so then the synthesis here, the big idea in this lesson is, do you have a reason for why corresponding parts are congruent? So why are corresponding parts of congruent figures congruent? So if we have two congruent figures, why are their corresponding parts congruent? So do you have a justification for that? And this is just a sample justification, so yours doesn't have to be as detailed as this. But ultimately, if the figures are congruent, then you can move one exactly on top of the other. So if you can move the figure exactly on top of the other, then that means that all the vertices and edges and angles will line up. So then that means that it's going to be congruent. So all of those parts are going to have to be congruent too, because they land directly on each other. So we have these rigid motions that move the figures on top of each other, meaning everything will line up. So corresponding parts are always going to be congruent if we have congruent figures. So then we've got some vocabulary here. You can choose to write it down if you want to. You don't have to. But corresponding means that when we move these images, so when we have a rigid transformation, okay, the part of the first and its image is in the second that land on each other are the corresponding. So BC's image is EF. Those are corresponding segments. BA and ED would be as well. CA and FD would be as well. And then you also have corresponding angles. A with D, C would go with F, B, angle B would go with angle E. So those are the corresponding parts, basically the ones that land on each other. So then you can underline this stuff in your summary if you want to. It gives you the definition of corresponding and talks about if two figures are not congruent, then there's not a rigid motion that takes one onto the other. But if there is a rigid motion that takes it on, then they are congruent. So hopefully after this lesson, you can identify corresponding parts. So you can identify corresponding parts from a congruent statement. So remember, that was if we said triangle ABC is congruent to triangle DEF. Those letters that line up. So if I took this and I just moved it over here, that tells you the corresponding angles. So A to D, B and E, C and F. And then it'll also help you with the side measures. So you'd have DE is corresponding to AB. So in your shape, right, you'd have DEF. So DE would be a side, that goes with AB. EF would be a side, which is going to go with BC. And then you'd also have DF would go with AC. Hopefully you can also use rigid transformations to decide if figures are congruent or not. So if there is a rigid motion that takes it to the next, then they are congruent. If there's not, then they're not congruent. And then hopefully you can also write your own congruent statement by matching up the corresponding parts. So make sure you practice this doing the lesson 1 practice problems. And then you can also try this cool down. And if you need help with your cool down, make sure you reach out to your teacher.